Well, hello scrappers, Mike here. Welcome back to my channel. What's going on up on the bench today? Well, today we are going to revisit the Iodine Leach and Yanni's really troublesome gold-plated bronze pins. Something about that bronze really throws a monkey wrench into the Iodine Leach. And I really want to get the Iodine Leach working, not just to deal with these pins, which I think Yanni has some more of, but also to deal with the 50 kilos of pins he brought me not too long ago. I'll put a link to that video in the upper right if you haven't seen it, but here's a quick excerpt. Yeah, check this out. Check this out. And like I said, this is just the beginning. There's so much more I have to show you. Oh, got some big ones in here. We tried sorting these out yesterday when Yanni was here, but we didn't get them all, obviously. There's some big ones in here, too, with lots of heavy gold plating on them. Yeah, I'm going to have to sift through this and get some more of those out. But my goodness, 50 kilos of pins of all kinds, all gold-plated. So yeah, I have 50 kilos of gold-plated pins that I need to get the gold off of. And the only way I can possibly do it is with a gold leach. I am not dissolving 50 kilos of metal with acids to recover the gold. That's just too much. So we got to get a leach working. I would prefer to be using the iodine leach over Eco Goldex. Just, I've had too much trouble with Eco Goldex, too many problems. So I think the iodine leach has a lot more promise to it. So we'll see. I just need to get past the bronze issue, and I think we're good to go. I've got gold off of fingers with the iodine leach with no trouble. And there's just, that worked great. So I think if I can get it working with these gold pins, I think it'll work with pretty much anything. So once more into the fray with the iodine leach and these pins. We're going to give it a try. So every time I've done this, I've done 300 grams. It's just a benchmark, a baseline. So I'm going to weigh out 300 grams of these pins again. And we'll try it again. We're going to do things a little different this time, though. First off, Owltech, thank you for sending me your new recipe. All right, I appreciate that. I haven't had a chance to try it yet. I will probably try that in a future video. But I have a whole bunch of mixed up leech already that's spent, and I know I can regenerate it. So we're going to regenerate it and try it on these pins. 301, close enough. Because I already have a lot of sodium iodide and crystal iodine invested in this stuff, and that's kind of pricey. So we'll regenerate this and use it. I'm going to do things a little differently. One thing people said in the comments section is I just wasn't agitating it enough. Now, you didn't see me agitate it all the time. The videos cover, sometimes as much as a couple of hours of time, and I was probably stirring it every minute or two, giving it a thorough stir. But you didn't see all that. So it was actually getting a fair amount of agitation, but certainly I could agitate it more. So that's one thing we're going to try in this video. Not only are we going to regenerate the leech and try the regenerated leech on it, we're going to try some different agitation. We'll get to that in a minute. Now the leech, if you want to know how to make the leech, I'll put a link to an earlier video where I mixed it up, because this is already mixed up, it's already been used, it's spent, and it can be regenerated and reused. So that's what we're going to do in this video. But if you want to know how to make the iodine leach to begin with, what you need to do, you can look at the video linked in the upper right now, and that will tell you how to mix up the leach solution, okay? But we're going to try regenerating this and see if with a whole lot of extra agitation, and another change I'm going to make is we're going to give this at least 2 treatments. So I'm going to mix up maybe close to 1 liter of the regenerated leach, and we'll put, I don't know, maybe 300 milliliters or so on these and agitate the heck out of it for a while, drain the stuff off, put another 300 milliliters on, agitate the heck out of it for a while, drain it off. And then if it looks like there's still a significant amount of gold on the pins, we'll do a third one. I think that multiple treatments are probably the way to get the gold out of this. It seems to me like if I leave the leech on this stuff for too long, it stops going after the gold and starts going after the tin and copper, okay? That's what seems to happen. When I first put the leech on, it seems like it's going great guns after the gold. The gold gets really dull, it starts disappearing, but then it kind of stalls out and the liquid loads down with copper and tin. So I think if I don't leave the liquid on as long, so it's going after the gold initially, and then dump it off before it starts loaded down with copper and tin, and then put fresh liquid on it and do that a couple of times. Maybe we'll get all the gold off without having to deal with so much copper and tin. We'll give it a try anyway. We'll give it the old college try, as they say. So that's my plan. So the question is, how am I going to agitate? And we don't need a label in there. We'll get that out. So the question is, how am I going to agitate this differently? Well, let me show you. To start with, we're going to use a different container to do this in. We're not going to do it in a beaker. No. We're going to do it in a great big jar. How does that help, you ask? Well, I suppose I could just stand here and shake it the whole time, but I got a better idea. We're going to put the pins and the liquid in here, and then we're going to do something special with the jar. Let me show you my idea. So what's my brilliant idea? Rock tumblers. Okay? Another one of my many hobbies is rock tumbling. In fact, I have a whole YouTube channel dedicated to lapidary arts. I can put a link to that in the upper right, as well as down in the video description if you're interested. I have found that there is some crossover between the people who watch my gold channel and the people who watch my lapidary channel. There are people who watch both, amazingly. It's two such different things. Anyway, I have a lot of rock tumblers. These back here are very large. It's hard to tell, probably, just how big they are on video, but my big hands for scale, that's a 12-pound rock tumbler right there, okay? So my idea is we're going to tumble the pins with the liquid for constant agitation for a given period of time and see how much time it takes. Now, my rubber rock tumblers, these are made of rubber, are very expensive. These things cost a lot of money. I don't know what the chemicals will do to it. So I'm not going to do it in this. No. We're going to do it in a glass jar. And then I'm going to put it up here. Just like that. And agitate it for a given amount of time. And we'll see how that does. So let's get started. First thing I need to do is regenerate the leech. And then we can get moving. All right, let's get started. I'm going to pour out about a liter of this spent leach and regenerate it. Now, this has been sitting around for about a week and a half, maybe a little longer, and a fine precipitate has come out of solution. I think it's just some metal hydroxides that were slow in coming out of solution. It looks like really fine, lightweight, fluffy stuff. It doesn't look like gold, so I'm not too worried about it. Besides, even if it is gold, that's what we're here to recover today. So we'll get it if it is, but it really doesn't look like it is. All right, so we got a liter of the spent leach. This stuff should be very alkaline. Got my pH papers here. We'll take a look. Litmus, another word for it. Oh yeah, very alkaline. Up around 12. So yeah, we are very, very alkaline. To regenerate this, I need to bring the pH down to 7 or below. And probably add some hydrogen peroxide to it if we don't wind up with getting free iodine in here just from changing the pH. Let me get a stir stick. And we'll start adding some formic acid to it. I have found that it does not take very much formic acid. Oh, wow, look at that. Look at that. We're getting free iodine already. That's great. Of course, it's going right back into solution, which tells me we're still too alkaline. So we'll put a little bit more formic acid in. And it looks like it's mostly going back into solution again. So a bit more. So Altec recommends the use of formic acid for adjusting the pH of the iodine leach. It doesn't add any chloride ions to it like using hydrochloric acid would. And it should escape the system as carbon dioxide when it reacts with the alkali in here. So we shouldn't actually be leaving a lot of residue behind. All right, let's have another look at the pH. I think I can reuse this paper. Let's see what we got here. Of course, now we got a lot of free iodine in there, so that's going to screw us up a bit. It looks like we are right around 6. So I think that's pretty good. I think that is pretty good. What I'm not sure about is how much free iodine we have in here now. I think I'm going to add a few milliliters of hydrogen peroxide to it just to make sure we've got plenty of free iodine. Our pH is where it needs to be, but let's see if we can free up some more iodine. Let me get a clean pipette, and we'll get a little bit of this. See what happens when it goes in. A bit more. It may not be acidic enough to free up a whole lot of iodine, but I do want to make sure we have, oh, I can smell it. I can smell iodine. Okay. So we have freed up iodine. We're getting iodine vapors wafting off of this stuff. So, okay. I'm not working in my fume hood. I'm outside, and the wind just blew a little bit of it towards me. So I would say we are probably good. There's free elemental iodine in here. The pH, Altec is recommending slightly alkaline. I think it's kind of tickling the dragon's tail, and you're probably going to have a lot of metal hydroxide crash out of solution on you before you really want them to, but you never know. I'll try his new recipe at some point, but I have a lot invested in this one, so we're going to go with it for now. So let me measure out 300 milliliters, roughly, of this stuff. This lovely purple liquid. All right, that's what we're going to use for our first treatment. Right there. And put the pins in here. All 300 grams of them. Come on, all of you in there. Everybody in the pool. Let's put this in. All right. Cap it up. And we'll go put it on the rock tumbler for 15 minutes. I'm going to do 15 minutes each treatment and see how well that works. All right, so it's now 2:08 p.m. And just in the time it took me to walk over here to the rock tumbling station, the pins have started looking dull. So I would say it's working. Not getting as much agitation as I'd hoped. You can spread them out a little bit. I don't know. I think I need ribs or something on the inside of the bottle. There is some agitation, but it's not great. But you know what? We're going to press forward with the experiment. I'll leave this on here for 15 minutes until about 2:23. And I'll take it off. We'll drain the liquid off, and we'll give it another treatment. And after 2 treatments, we'll take a look at the pins and appraise them and see whether they need a third. There is some agitation going on. So it's probably better than stirring it periodically and letting it sit, because we are getting some agitation. Constant agitation. So, okay, well, we'll be back in about, less than 15 minutes now, but we'll be back then and see what we got. Well, after a few minutes, I see we've got an interesting development here. The knob on the end of this tumbler has worked its way into the indentation on the bottom of the bottle, and well, suddenly we're getting a whole lot more agitation. So I was thinking that was going to be a problem, but now I'm looking at it, it's like, no, that's great. That's absolutely fantastic. We're getting even more agitation than I thought. So I don't think there's any way we're not getting enough agitation. So in about 10 more minutes, I'll pull that off and dump the liquid off. I'll have a quick look at the pins, and then start it with a second treatment and see where that gets us. But yeah, this is actually completely by accident. This is working better than I expected. I like that. I like that. All right, 15 minutes is up. Let's go over to the other bench, pour this off, and have a look. I can tell a lot of the gold is gone already, but not all of it. So let's go have a look. All right, so after 15 minutes, the liquid is starting to turn a muddy brown, but it hasn't gone too far that direction yet. I know if I leave the liquid on these pins for too long, it will start looking like coffee with way too much creamer in it. It's only slightly muddy brown and no longer purple. And I can see a lot of the gold has been removed from those pins. I don't know if I can give you a good look at it, maybe with my phone. There's still gold there, but a lot of it has been removed. Let me see if I can give you a close-up look at it with my phone, then we'll give it another treatment. All right, so here's as good a shot as I can get you of the pins down in there. A lot of the gold has been removed, but there's still gold there. I mean, I can still see gold in places, but certainly a lot of it has been removed, and in only 15 minutes, which is pretty darn good, considering it was taking me longer than that to get to this stage before. And look at the difference in the color of the liquid here. What we started with over here and what we poured off. But it's still pretty clear. It hasn't loaded down with a lot of what I assume is tin iodide. So, yeah, okay. This seems to be working. Let me measure out another 300 milliliters, and we'll do it again and see what the pins look like after another 15 minutes. Okay, and we'll just keep adding our spent liquid to that. Let me measure out another roughly 300 milliliters of this stuff. The good purple stuff here. Yeah. Oh, I'm making a mess as per usual. That in there. Lid it up and get it back on the machine for another 15 minutes. Let's see how it goes. And we're going again. We're getting plenty of agitation, and that is something I'm very happy about. So we'll just let this go for another 15 minutes. What's the time right now? It's 2:27, and I probably put this on 2 minutes ago. So we'll say it started at 2:25. I'll take it off at 2:40. All right, this has been on for another 15 minutes. Let's dump it out. And to use this sieve, getting a little smarter in my old age, to get more of the liquid off, and if any pins come over, I can catch them in it. Actually, don't think any pins came over. One or two. Yeah. Okay. I'm back in there. All right. Back in there, you. All right. Well, it's looking a lot better. I still see a little bit of gold in there, in spots, but that's looking a lot better. So these pins are made of bronze, and the shiny bronzy areas can kind of look like gold too, but I think there still is some gold in there. Let me give you another look close up with my phone. Yeah, it's getting hard to tell whether that's gold or not, but I think I do definitely see gold in places. It looks like gold down in there. Maybe some gold over here. Maybe a little bit of gold up there. So I guess we're going to give it one more treatment and see how that does. And we are off and tumbling for the third and final time. It is 2:43, so I will pull this off at 2:58. And we'll see what the pins look like then. All right, let's pour off this last batch and have a look at the pins. I'm going to give them a little bit of a rinse with some distilled water here. Get pregnant solution out of it. Actually, you know what? Let me dump some of the pins out and we'll have a look at them close up. Yeah. That's the way. All right. I don't know. Let me give you a close-up look at the phone and show you what's going on in that strainer. All right, it looks pretty much like last time. I still see a little gold here and there. They're not perfectly clean, although I think they look pretty good for the most part. But yeah, there's definitely some gold here and there, some gold down there, some gold down there, some gold down there. I think we got the vast bulk of it off. I think I know what I did wrong. And I even intended to do this before we started, and I forgot. I was going to tumble the pins for a while in soapy water to get them good and clean. The remaining gold, maybe because there's oils or grease left behind on those that's preventing the leach from getting to it. That's possible. Let me mix them up a little bit here. Yeah, there's just a little bit of gold here and there, it looks like. It looks like we've got the vast bulk of it off. Yeah, so that remaining little bit of gold on there could be my fault for not cleaning them first. So people yell at me in the comments all the time that I need to clean stuff first before I use a gold leach on it. And they're right, and I intended to do it this time, but it completely slipped my mind somehow. I guess I was eager to get this going because it's supposed to rain later. I wanted to get it done before the rain started. But certainly we did get the vast bulk of the gold off of them. And without turning this stuff into, you know, a very light brown, thick mud, like normally happens when I use the iodine leach and leave it on the pins for a long period of time to try and get all the gold off. Now we do have a little bit of a light colored precipitate down here, so I think we did pick up some tin. But again, it's nothing like what it normally looks like. I would say this is an improvement. So, all right, here's what I'm going to do. I'm going to store these with other pins I've used the iodine leach on that still look like they have some gold on them. So we may revisit these pins and see if we can get the rest of the gold off of them in the future. Clearly, I need to do this experiment a second time and remember to clean the pins first. So we will do that. But let's see how much gold we recovered from the dirty pins. So to do that, I need to precipitate all of the metal hydroxides out of solution here. Right now they're in the form of iodides, iodates, and iodine complexes. They're held in solution except for this white stuff that's come out, which is probably some tin compound. Tin is always the enemy. But I've got some potassium hydroxide here. We're going to use this to raise the pH back up about where it was here before we regenerated the leach. And then everything in solution should just crash right out. And this should not take too much potassium hydroxide. Anthony Thomas, if you're watching, this should not take too much potassium hydroxide. If you use, a mild acid like formic acid to adjust your pH down, you're not going to need too much potassium hydroxide to adjust your pH back up again. So what should happen here is that this should darken. And we should get, oh yeah, the color's changing a little. And we should get a precipitate. Oh yeah, we are getting a precipitate. Oh yeah. Oh yeah, I think I've got more than enough potassium hydroxide in there. Oh yeah, look at that, it's green. That's interesting. It's green. Yeah. But yeah, we're definitely getting a precipitate. Let me find my pH paper and test it and see if we have the pH up high enough or I need to put more stuff in. So I would say we did dissolve some copper since it's turning green here. Where are we? Oh, we are maybe only about 11. I'll put a little bit more in just to make sure we get all of the metal hydroxides to crash out of solution. Let's see where we are here now. That might be thunder. All right. That might be thunder. What's going on here? Okay, I'd say that's 12. All right. So we're just going to let this sit and let all of the hydroxides in there settle out. And then we will go on to try and capture the gold that should be in there, along with all those metal hydroxides. All right, let's filter this liquid now that the solids have mostly settled out of it. Let's filter it and catch them on a filter in here. I'm using a filter paper in my fritted funnel just to keep any insoluble debris from getting down in the frit. Just keep my fritted funnel clean, basically, is why I use a filter paper in it. So let me get my pump started, and we will vacuum filter this stuff and capture. Oh, that thunder seems to be getting louder. Yeah, try something here. There we go. I'm not expecting there to be anything of value in the liquid other than reusable leach, which could be reconstituted and reused again. All of the values are down in the solids down there. So that's what I'm trying to capture. Those solids should consist of metal hydroxides, tin, copper, any other metals in those pins, and gold. So I think we can just pour it in now. There we go. That beaker was pretty full before. So I'll get all the liquid through first, and then once I pour the solids in, things are going to slow down. I'm going to take the first batch of liquid I filter off, and I'm going to put it back in the spent leach bottle for next time. And then we'll give some rinses to the solids once they're up in there. Get them cleaned up. So the solids are in here now, and I've been pulling the leach liquid out of it. It's drying up nice. Every once in a while a drip still comes through. I'm going to let the pump run a little while longer and get this stuff as dry as I can. Then I'm going to transfer this liquid back into my spent leach storage bottle. I've put the pins into this bag after iodine leach. So there's a lot more than 300 grams of pins in there now because I've done this a few times, but any gold left on those we'll get somehow in the future. But yeah, as soon as this is done and I pour this over, I'm gonna start putting some distilled water through here to try and get the rest of the leach solution out of this material before we go to try and recover the gold from it. I figure I don't want to fight the leach while I'm trying to recover the gold. Alright, I have transferred the spent leach from here back into the storage bottle. We're right about exactly where we started, right around 1400 milliliters. I'm trying not to dilute it too much so that I can reuse it over and over again. At some point I'll probably have to add some more potassium iodide and crystal iodine to it just to keep the strength up, but I managed to get through this batch without really diluting it, so that's great. Let me run some distilled water across the mud up here, or through it I should say, to try and pull the remains of the leach out of it so that we don't have to fight it when we're trying to reprecipitate the gold out of solution later. So I want to get as much of the iodine compounds out of it as I can, so we'll just let that run through there, and I'll probably give it a couple additions of distilled water and suck it through the mud with the vacuum and hopefully take iodine compounds out with it. Then we'll be ready to move on to the next step. From here on out, it's just like, you know, I've done it all the other times with the iodine leach. So it's really no different at this point. We'll see how much gold we get in the end. All right, so our mud is up here. I have pulled a lot of distilled water through it to get the leach chemicals out of it. And that mud consists of metallic hydroxides and our gold. So I want to get the metallic hydroxides into solution. The gold won't go into solution, what I'm going to do next, but the metallic hydroxides will. So I've got some muriatic acid here. I'm going to make up a 50-50 mixture of muriatic acid and distilled water. There's about 200 milliliters of muriatic acid. Put in about 200 milliliters of distilled water. Right. I'm going to put our mixture right in here. I'm not going to use the vacuum to pull it through. I'm just going to let gravity do it. And that's going to dissolve a lot of, well, it's going to dissolve all of the metallic hydroxides in here. It's already dripping through slowly. Yeah. So what I will do is, once this goes down some, I'll put some more of that in it. and I will keep that up until it's all gone through. And then what I'll probably do is dump the liquid in the flask here out back into this beaker and run it all through again, just to make sure we dissolve as much of those metallic hydroxides as possible and get them out of here. I mean, look at this. This is coming through green. It's coming through green. So, yeah, that tells me we are dissolving metallic hydroxides and getting them out of our gold. Excellent. And my stepson wants something. Let me see what he wants. Yeah, it's really coming through green now. I suspect that would be copper chloride we're seeing coming through there. So that's good. We're getting the base metals out of the mud up here at the top. And should be left with nothing but gold in the end. So we'll just let this go. Like I said, once this goes through once, I'll run it through a second time. And then I'll run some rinse water through to get the green stuff out of it. And then we should be ready to dissolve the gold. All right, I have run this acid through twice, and it's gotten quite yellow-green. I just picked up whatever was in here. I'm sure there was a lot of copper and tin, maybe some other stuff too. But what's left should be pretty much just gold. I'm gonna put a bunch of distilled water through just to get the green stuff out of it. And then we'll be ready to go to Aqua Regia and try and dissolve the gold out of here. Oh yeah, that's a much better looking stuff after running a bunch of distilled water over it. I want to do a stannous chloride test on the liquid down here in the flask, just to make sure we don't have any dissolved gold in it. All right, let's set this aside for now over here and get a little bit of that liquid. The color is very suggestive. That doesn't mean there is any gold in it, but the color is suggestive. So, we'll check it. We don't want to throw any gold away. And there's nothing. Good. Absolutely nothing. Not even the slightest trace of purple. Good. All right, so this is a waste product. It looks like it's got a lot of copper in it. Probably some other stuff too. But that will go in through my waste system, and whatever copper's in it will cement out on the iron I keep in my waste buckets. So I'm going to dump this out in my waste bucket, clean the flask, and then we'll be ready to dissolve the mud that's left in here, which should be gold now, in Aqua Regia. So we'll do that next. All right, since we should have pretty much nothing left but gold in here, it's time to dissolve it with some Aqua Regia. So I'm going to make up some fairly strong Aqua Regia. I'm going to do about 300 milliliters hydrochloric acid. Whoops, sorry. My big size 13-foot kicked the tripod leg. Sorry about that. And I'm going to put in, let's see, that's 50 milliliters is the next one. So we're going to go with maybe about, eyeball about 30 milliliters nitric acid. That's going to be some strong Aqua Regia. But the reason I'm making it strong is it's not going to be resident on the gold for very long. I'm going to do what I did before. I'm going to pour it through and let it drip through on its own under gravity. And it should dissolve that gold on its way. A little bit of reaction in there. It should start dripping through. There it goes. So far it's coming through pretty clear, but hopefully it'll start looking like it's got gold dissolved in it. Well, we'll just let it go, and I will dump the rest of this in after it's come through. And it's like I did with hydrochloric acid, I will run it through a second time. I'll just dump this back out into this beaker and run it through a second time and make sure we get all that gold dissolved in there. Oh yeah, it is turning yellow. Yeah, of course this is turning yellow too. When you mix hydrochloric and nitric, you get, I forget the name of the compound that's yellow, but that's the stuff that dissolves gold. But yeah, it's coming through. It's looking like the right color. We'll just let it go. It's getting late in the day, but I think we got time to get this done before it gets dark. Now, can you see the fizzing and the bubbling in there? Yeah, gold will dissolve even in cold aqua regia. So yeah, it's definitely dissolving. There's a lot of bubbling going on. Alright, so our gold's going into solution and slowly dripping through. Excellent. Everything is going to plan. So you may well be wondering to yourself, if you haven't seen any of my gold leach videos before, am I really getting any gold out of this? This looks sketchy, right? Well, let's see. Let's see if we're getting any gold out of it. Let's do a stannous chloride test. I really only want one drop, but I'm probably going to get more. There we go. There's one drop. Good. Let's do a stannous chloride test. I will zoom in on the spot plate. I'll put a drop of stannous chloride on it and see what we got. Boom! Oh yeah. Look at that. Look at that. Yes, we have gold. And that is a really strong indication for gold, as it should be. Yeah, it's dissolving away in there good. It's bubbling. Yeah, we got a real good reaction going on in here, and that stuff is disappearing. So yeah. All right, everything is just working perfectly. So I'm going to put a little bit more of the aqua regia through. And keep that up until it's all through, and then run it through a second time. Third time if necessary, but I'll bet before I'm even done with the second time, all that gold will be dissolved. Not my first rodeo with the iodine leach. I know what I'm expecting here. So, okay. It's going to take a little while since we're doing this solely by gravity. We'll be back when it's done. Yep, most of the aqua regia has gone through the first time. Look at that gold in there just bubbling away as it dissolves. What's left of it, most of it's gone. Down here now. But I will definitely run this liquid through a second time just to make sure I get every last trace of that gold in solution. It's going pretty quick, which is great. All right. All that aqua regia's been through twice. The filter looks amazing. There's no trace of gold in it. In fact, there's not much in it at all except some debris. I'm going to run a bunch of distilled water through here to get the pregnant solution out of the filter and the frit of the funnel. And for that, I will use the vacuum just to speed things up a little bit. Yeah. Then I'll give you a look in the funnel here at how clean the filter is. We definitely dissolved everything except for a little bit of debris. What it is, I don't know, but it ain't gold because it didn't dissolve in aqua regia. Yeah, we'll get all the color out of the filter. That yellow color, gold, so I want to try and get as much of it out of there as I can, though I am going to save the filter in Yanni's rag and filter bucket. We'll incinerate this one day and see what we can extract from it, along with all his other filters and rags. All right. We'll let the pump pull through the water through, and I'll give you a look at that filter. Check that out. That is one clean filter. Just some miscellaneous debris down there. What it is, I don't know, but I see a little piece of solder mask maybe over there. Actually, if you see, I see a few pieces of green solder mask, but yeah, I'm not surprised to see some debris. Yanni pulled all these pins out of PC boards. I'm sure some PC board debris came with him. But that's a pretty clean filter. Alright. Next, I need to denox this stuff. I'm going to mix up my usual solution of sulfamic acid to denox it, and I'm going to run it through this filter, just in case there's any debris in my sulfamic acid. You know, I buy the industrial grade stuff, not the, chemical grade stuff. So sometimes there's some debris in it. So we'll run it right through the same filter, and we'll get this stuff denoxed. So right about now, the battery in my Bluetooth microphone died. So I'll give you some voiceover on this segment. I'm explaining that this stuff has sat around since the night before because it was really late and I wasn't going to continue in the dark. So I just left it in the fume hood overnight, brought it back out, and we're going to denox it. I'm going to run a saturated solution of sulfamic acid here right through the same filter that I've been using all along, just to make sure that there is no debris going into the gold, because the sulfamic acid is industrial grade. It's basically used for cleaning tile grout, okay? Works great for this application though. I mixed up a lot of it because there's a lot of nitric acid in this stuff. I used a really strong aqua regia. So I'm explaining that I mixed up a lot of the sulfamic acid solution. I wanted to make sure this was thoroughly denoxed. Going to pull it through the filter with the vacuum. And as you can see, or maybe you can't see, but there's a lot of fizzing going on in the flask down there as it hits the aqua regia with the excess nitric acid in it, and it is doing a good job of denoxing that liquid. So I'm going to make sure I get the rest of the liquid through, and there is some sulfamic acid left in the bottom of this beaker. I'm going to add a little bit more distilled water to it, see if I can get it to dissolve, and I'll run it through too, just to make sure we are thoroughly denoxed. Plus, this is also going to dilute the aqua regia a little bit, which is going to help the gold come out of solution. Gold likes to come out of a dilute solution rather than out of a concentrated solution. All right, it's time to drop the gold and see how much we got. So I'm going to use iron sulfate for that. I've got some acidified iron sulfate solution here. Use it to drop the gold. I've had a little trouble using SMB with the iodine leach. I don't know why, but we get some sort of strange milky gray precipitate when I try to drop gold from the iodine leach with SMB, but everything seems to work just fine with this stuff. So, well, I say that, then I put a bunch in and nothing much happens, huh? Oh, there we go. It just had to think about it for a second. Oh yeah, it's darkening up. Oh yeah. Getting a gold drop. I can put a little bit more in. The beaker's not quite full. Oh yeah. Just to make sure we get a complete gold drop. Oh yeah. There we go. Excellent. Excellent. All right, we'll just let that sit and settle out, and we'll see what we get. All right, this is kind of cool. You can't see much looking at it from this angle, but look at this. Look at the particles of gold swirling around in there. Yeah, nice. Getting a film of gold on the inside of the beaker. I think it's starting to settle to the bottom, so that's great. So we'll just let this sit and settle. Once the liquid clarifies, do a stannous chloride test on it to make sure we've got all of the gold out of solution. If not, I'll transfer it to a larger beaker and put some more iron sulfate on it. But I think we're getting a pretty good gold drop. I think it's all going to come out of solution eventually. It's going to take a little while. Wow, that is one full beaker. But Look, the liquid's cleared up. There's a layer of gold on the bottom. It's been maybe a half hour, half an hour. Okay. Another thing I like about using iron sulfate is the gold settles out fast. It doesn't hang around in solution for a long time, even the fine particles, because if you use an SMB, it produces a lot of sulfur dioxide gas, and those gas bubbles buoy up the fine pieces of gold, and they don't want to settle out. It can take a very long time. You wind up having to boil it maybe to degas it and get the liquid to settle. It can take a very long time. Anyway, let's see if we've got all the gold out of solution. Get a little bit of this liquid up here. All right. I'll take it over to the bench and do a stannous chloride test on this green stuff and see if we've got any gold left in it. All right, let's hit it with a little fresh stannous chloride. I've got a video on how I make stannous chloride whenever I need it, pretty much on demand. It's quick and easy, and it's always fresh. Nothing. We got a whole lot of nothing going on there. So we got all the gold out of solution. It's on the bottom of the beaker. Excellent. So what I'm going to do is I'm going to get the beaker out very carefully because it's very full, and I'm going to siphon that liquid into Yanni's stock pot, and then we'll start cleaning up the gold so we can get the liquid out of it, the remains of the liquid out of it that we precipitated it from, get it consolidated hopefully with some boils, and then dry it out and weigh it and see how much gold we got. Alrighty, if you've watched my videos, you know what I do next. I've got the gold transferred to a much smaller beaker with some distilled water. We're going to give it some cleanup boils. It's just now heating up towards its first boil. I'm going to turn the heat up a little bit more and get it going. I'm going to give it at least 3 cleanup boils in distilled water. I will decant the water off between boils through a filter to capture any fine gold that might come over. We won't lose that. That filter will go in Johnny's filter and rag bucket for later recovery. And then once I've given it 3 boils, we're going to dry it out and weigh the powder and see how much gold we recovered this time around with the iodine leach. Alright, the gold has had its 3 boils in distilled water. We're going to dry it out slowly on low heat. And once it's good and dry, we'll weigh it up and see what we got. Calculate a yield. Alright, so here's the gold I recovered. So let's give it a weight. See what we've got here. This is good looking stuff, by the way. Alright, so I set a benchmark a while back by actually dissolving the pins in poor man's nitric acid and then recovering the gold. And that was a battle. That was a battle because all that tin made it very difficult to do. But I wound up with about 1%, a little over 1% by weight gold on the pins. Okay? So we don't have anywhere near that much here. Let me calculate a quick yield. So let's see here. We started out with, well, we got 1.36 grams divided by 300 grams, which is what we started out with. So yeah, 0.004. So yeah, we are somewhat less than 50% of what I got by dissolving the pins entirely. So the iodine leach just isn't working all that good yet, at least not on these high tin content pins. Yeah, I need to do more work on it. I'll run another test and I'll remember to clean the pins really well and try and get any oil and grease off of them. Soap and water may not be good enough. Anthony Thomas tried soap and water and he didn't get all the gold off his pins either. He didn't think so. I might need a solvent, maybe acetone, something like that. Try that, we'll see. But yeah, we got to get the yield up. I'd like to have the yield within 10% of what I get by dissolving the pins entirely. I don't know if that's possible, but that's where I'd like to get it. in order to rely on the iodine leach for getting most of the gold out of these pins. Of course, I could try some other stuff too. I can try, I gave it 3 treatments. I could try 4 or 5 treatments. I could also increase the concentration of the chemicals in the iodine leach. I was using regenerated stuff. I'm sure it got a little bit weak. So I could try something a little more concentrated. I went with an arbitrary 15 minutes per cycle. I could maybe go a little longer. There's lots of different ways I can experiment with. I like the iodine leach in theory because I can scale it up. Let me show you what I mean. Yeah, scaling up the iodine leach I think would be easy if I can get it working as well as I want it to. I have lots of containers that I can run on my big rock tumbler. In fact, I could probably get 2 of these at a time on there. And I was only using 300 grams of pins at a time. I can probably easily up that to half a kilo or more. So yeah, this scales nicely. And seeing as I have 50 kilos of pins I need to deal with and a bunch of other stuff, I'm looking for a way that scales nicely. So, but it's got to be better than that. It's got to work better than that. Yeah, we got to about double the yield, close to double it anyway, before I'd say it is gonna work. So, if you guys have any suggestions, let me know. I will probably be trying the new recipe you sent me. Haven't got around to it yet, but thank you for sending it. I'll give it a shot. I'm not having too good a luck with this older recipe. I'll also be trying this stuff on the new batch of 50 kilos of pins that Yanni brought me because they are a different composition. In fact, they're every kind of composition. They are a big mix of pins. But they aren't, all high tin bronze like I've been working with. So we'll see how well the leech works on those. Hopefully better. I guess we'll find out. Well, if you guys found this video at all interesting, educational, entertaining, inspirational, whatever, give it a like, give it a thumbs up, and subscribe to see future videos. And I'll be back in the next video. I'll see you then. Bye. Hey, it's Mike again. Okay, so here's some pro credit content for you. It's hard to believe that the iodine leach has only taken off half the gold, but multiple tests now, a lot of which I've done off camera, it's like we're getting 2/3 to only half of the gold that I was getting by totally dissolving the pins away. Even if the pins look like the vast majority of the gold is gone, we're not getting as much as we ought to. So I'm wondering, is the gold actually being left behind, even though the pins don't look like the gold is being left behind? Or is the gold ending up somewhere else? Now, this is my spent leach bottle. And I've been experimenting. I've been doing stuff in the background over here, working with stuff off camera, trying to figure this out. And there's a sediment in the bottom of my spent leach bottle. It doesn't really look like gold, but what if it is gold? What if the gold, or at least some of the gold, is staying in the spent leach and then precipitating out later, over time? I mean, it took the better part of 2 weeks for all this stuff to precipitate out, whatever it is. So what I want to do is I want to capture this stuff on a filter. We'll put this filter in some aqua regia, and we'll give it a test with stannous chloride and see just what we're dealing with here. If it's gold, it's got a scum of it on the inside of my bottle here. It's not coming off. If it's gold, we'll know that some of it's just staying in solution. If it's not gold, and it's just some sort of, I don't know, heavy metal hydroxide, well, at least we'll know that. Didn't get all of it out, but got most of it. There's definitely a scum of it on the sides of that flask. But if this does turn out to be gold, I can just run some aqua regia and swish it around in here and dissolve it. We'll see. So we'll let this filter through. I'll run some distilled water over the filter to get the leach out of it. And then we'll put that filter in Aqua Regia and see what we got. Well, there it is, whatever it is. Let me rinse it down with some distilled water here. Let that drain through. And we'll put this in some Aqua Regia and figure out if it's gold or not. Alright, let's find out what this crap is. Or isn't. There we got whatever it is down here in the bottom of the filter. You know what, I'm just going to put the whole filter in. I was just going to tear the top off and put it in, but you know what, I don't really care. Alright, let's get this in the fume hood and make some Aqua Regia and then do a stannous chloride test on it. See what we got. Alright, let's make some Aqua Regia. Oh, that's interesting. Immediate big color change in the filter. I don't know what that means, but it's interesting. Alright, so that was muriatic acid, some nitric acid in there. Not too much. Not a lot of material there. That's probably more than enough. And we shall see what happens. I'm going to put a little bit of heat to it. Give it a stir here. I suspect that dark color is iodine coming out of solution, but I don't know for certain. Let's see if there's any gold in this. We'll let it sit and simmer for a bit, and we'll give it a stannous chloride test. Alright, I may have put a bit too much heat to it too quick. I started boiling, but look at that. The Aqua Regia has bleached whatever that color was. I assume iodine right out of the paper in there. So, I guess it's time for the moment of truth. Let's find out if we actually have any gold in this stuff. Some on the spot plate here. Stir it up a bit. Okay, let's do a stannous chloride test on it over here and see what we've got. What do you know about that? Okay. What do you know about that? Okay. So, yeah. I found out where some of the gold went. It's staying in the leach solution and then precipitating out over time. And whether all of it precipitated out or not, I don't know. That's a good question. Maybe not. Am I not getting the pH high enough to precipitate out all the gold, or does it need something besides high pH to precipitate out? I don't know. So at least some of our gold is staying in the spent leach solution. That would explain a lot. Okay, so we got two problems here. Number one, the leach isn't taking all the gold off, although that may be a matter of me not getting the parts clean enough before putting them through the leach. And number two, not all the gold is precipitating out of the leach. Okay, that's important to know right there. And I got to figure out how to make the rest of the gold precipitate out. Got lots of thinking to do and probably a lot of behind-the-scenes experimenting. Owltech, if you're watching, that's important to know. Anthony Thomas, if you're watching, this is an important revelation. Okay. Now the video is over. Thanks a lot for watching. I'll see you in the next one. Bye.